I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will discuss the topic on latches for the course Digital System Designs. So far, we have discussed the combinational logic circuits in Unit 2, and the combinational logic circuits are the simplest type of circuit in digital systems where the output depends only on the present input. Since the output depends on only the present combination of input, it does not require any memory element and no clock signal is required, and it is the simplest type of circuit. For example, we can say half adder, full adder, multiplexer, code converter circuits. But while comparing to sequential circuit outputs are not only depends on the present combination of input, they also depends on the past output. So here we can understand that to store the past output, we require a memory element, and here in sequential circuits, clock signal is also required. And examples we can say flip-flops, registers, counters, latches, etc. So, taking a digital memory, for example, every day we are using a digital device. So, from smartphone to the supercomputers, they always relies on fundamental memory building blocks, which stores and the maintain the information. To store and maintain the information, we need a basic building block which stores a single bit of information. They are latches. So latches form the foundation of the memory hierarchy. So this is the reason why we can understand the latches are very important in the foundation of digital memory. And empathizing, what is the need for latches? We have seen all the digital systems require memory to store and maintain the binary state, either it may be 0 or 1. And the solution is latches because they form the basic temporary storage device. And the question is how binary information will be stored by latches reliably. So, empathizing is nothing but understanding user needs. So, here the user here is the digital system. So, understanding the digital system need, for example, if we take processing unit considering CPU, central processing unit, in order to hold intermediate calculations and maintain state information between operation, it needs a memory storage. And control systems require memory elements which respond immediately to input changes for real-time system control. And interface circuits need buffer storage to temporarily hold data during transfer operations between different system components. So all these systems require basically a memory unit. So here a latch satisfies that. Latch is a building block of a sequential circuit capable of storing one bit of information, and it has two states. One is Q and another one is Q bar or Q complement, and these two states are always complement to each other, and it is built from logic gates, either NAND gate or NOR gate. And this latches does not require clock signal, but instead it have a enable signal, and output changes only when enable input signal is applied, and the latch is always level trigger device. And latch is a bistable device which is having the inputs and two outputs, and it is level sensitive so that the output will be reliable, and the Q and Q bar is always complement to each other. This also ensures the reliability. And there are different types of latches available in the ideate stage. One is SR latch and another one is T latch and gated latches. SR latch, S represents set, R represent reset, and they two S and R are inputs. When set is 0, the output is 0. When reset is set is 1, the reset output is 1. And when set is 1, the system will set, and when reset is 1, it will reset. And a D latch is nothing but a data latch. So it stores the single data input, and when data input is 0, the output is 0, and if it is 1, the output is 1. So we can understand that D latch holds the data, and the gated latches are the third category. They include an enable signal that controls when input changes can affect the output. And these are the truth tables of SR latch and D latch. When both inputs are 0, 0, Q is hold and Q bar is also hold. It means S and R are 0, then it acts as a memory element. When set is 0, output Q is 0. When set is 1, output Q is 1. When both are N in SR latch, it is invalid state in SR latch truth table. And coming to D latch, when the enable input is 0, it acts as a memory element, whatever may be the input. But when the enable is 1, if the input of D latch is 0, the output is 0. If 1, the output is also 1. And activity. So now advantages. So there are so many advantages of latches. Design flexibility is very simple when compared to flip-flops, and power efficiency, it less consume less power, high speed performance because it is level triggered, and aggressive clocking it will allow. Time borrowing, so they can borrow times when other circuits be complete operations, and size is very compact. And applications, there are variety of applications of latches. Basically it is a memory element, even though it will give application to binary encoding and circuit storage, asynchronous systems, it is a very important part, and it also be in synchronous system also. So now assessment is what happens when both SR inputs of SR latch is high. When it is high, so it is invalid state, so that we can go for D latch. And next is the difference between transparent and opaque modes in gated D latch. So in transparent mode, if enable is equal to 1, output follows the input change immediately. But in opaque mode, En is 0, enable is 0, output holds the previous state. And third question, why the latches are called level sensitive devices? Because they response, latches responds to always a logic level of enable signal rather than the edge transition, positive edge or negative edge. So it is active. So summarizing, so far we have seen the logic circuit, empathy part, the need of latches in digital systems, and also we have defined the core problem, and it is a latch design we have seen, and it's a truth table, and also we have discussed about advantages and disadvantages. References. Thank you.